Hello everyone, this is Dave, and I'll give you some hints here for question 1B on assignment 2. The idea is that you should have solved question 1A, you know how to print triangles, you have a basic idea about how recursive functions work in C, and you've thought about the algorithm to print the Sierpinski triangles yourself a little bit. Maybe you're stuck, or maybe you just want to see a little bit of my hint so that you just save yourself time. But I would say that you're going to have more fun if you can solve the problem yourself. And so, maybe if you haven't thought about it much yet, you might spend 5 more minutes, 10 more minutes to see if you could come up with something without the video. And even while you're watching the video, if you think, okay, from here I could continue on, then I'd actually recommend only watching part of this and stopping. If you can finish the last part yourself, that's going to be the best learning experience, just for systems programming and for the midterms and everything. Okay, here's my way of thinking about the problem. Well, this is the problem. It has, depending on the level of triangle, we have to make a more and more complex shape. It's a recursive pattern, which means the way we make it more complex is we copy little instances of the previous level into our shape, essentially. That's a little bit different way than I described it in the assignment, but hopefully you can see that that pattern's happening here. So we just take that really seriously. We start drawing boxes and thinking about every single part of the box. Where does it come from? The blue box has 3 red boxes inside it, and it has some space which is not covered by red boxes, right? So 3 red boxes means we would run code to print the simple triangles, and space means we need to run some kind of extra operations and just make sure those things happen in the right spots, each one. Okay, the spaces, main big spaces are here. There's also one space on the bottom row, right, between the 2 red boxes, right? Okay, so how do we exactly do that? It's coming up, but if we could do it, well, that would actually solve the entire problem for us, right? Because that pattern from level 2 being built up of 3 level 1s is actually true of level 3 as well. Level 3 is built up of 3 level 2s, and of course that's built up each one of 3 level 1. So level 3 is built up of 9 red boxes of level 1, and just the right spaces that are strategically located all around. Okay, so if we organize our code in a way to print just some spaces when they're needed, some level 1 triangles when they're needed, and we keep track of all the heights and everything along the way, we'll be set. So it's not too hard once you kind of picture that. Maybe some people would be stopping now and saying, I could figure out how to take this picture and translate it into code myself. Other people, continuing on, no problem. Let's look at a little bit more detail, the pseudocode and how to break this down in my way. I recommend making a main function. It loops over the pattern row by row. Each row delegates to a helper function called print row. Print row has 3 arguments. Row means where are we in terms of the row 0 or row 1 being the top, and row h being the bottom. So it's a variable that says how far are we from the top, and h is our height of the triangle that we're supposed to print. Notice that there'll be a relationship between the height of the triangle and the height of the whole diamond. I'm only going to help you print the triangle here, and I hope that you'll be able to figure out how to make the diamond after that works. And then level, that's how complicated the triangle should be, how many times we decompose. If we could print that row with our helper function, then all main would have to do would be to print the new line at the end to warp us back to the beginning of the next row. Okay, so all the work happens in print row. That's the recursive function that we need to think about. What is its structure? Its job is to print rows. There's 3 different types of row that it might need to print. A level 1 row means we're just printing a triangle just as though we were doing question 1A. For more than level 1, for level 2 and beyond, we need to think about something different happening in the top rows versus the bottom rows. Top half versus bottom half. Top half, we do some of those spaces. We do a level lower triangle, which is half the height. We do some more spaces. In the bottom row, bottom half rows, we do half the height triangle, a single space. There turns out to be 1 column of spaces between the 2 red boxes on the bottom, and then another half the height triangle. Okay, so as long as we could write some C code that decomposes those rows in that way, we'd be all set. Maybe other people might want to stop now and think about the pseudocode themselves. And if you're finally ready for the full recipe, everything will be revealed on this last slide, where print row is a recursive function. It takes these 3 arguments I mentioned. It has a recursive base case. If level equals 1, we do some computation just to figure out how many stars and spaces on this row of triangle of height h, and well, level will be 1, so there's no recursing, right? So we just print stars and spaces and return. Nothing complicated for the base case level 1. If we're in a top half row, we print a small box of spaces. That thing should be about width over 4. We print row of this more simple triangle at half the height, and our row variable is still what it was for the bigger box, because the top row triangle has the same top as the big triangle. And then we print some more spaces. If we're in a bottom half row, we basically print those 2 triangles separated by 1 space, right? Print row, print 1 space, print row. The only tricky part here is what should the row variable be, because the point of the bottom row triangles are not equal to the point of the top triangle. They're halfway down, right? We essentially move the row, we reduce the row that we're at by half the height of the big triangle. That's it. I hope that you would be able to translate this recipe into C code by now, and of course post questions on my courses. Best of luck, and I'll see you just after Thanksgiving in person.